I'm going to solve the second problem of the third partial exam of electricity and magnetism that says like this. A battery with a voltage of 1.5 volts is connected to 3 resistors as shown in the figure. We have first to find the potential drop across each resistor, and then we have to find the current in each resistor. The potential drop is the voltage in each of the resistors. So I'm going to solve it in here. First, the first part. For solving according to the voltage, we have to consider this formula, that the voltage is equal to the resistance times the current. And we have to determine first which is the relationship between the resistance. Here we know that these two parts are in parallel, but here we have two resistance in series. So we can determine that the voltage here, that is voltage 1, will be equal to the sum of the voltage in 1 and the voltage in 3, because these have to be summed in series in order to be connected to the other one that is in parallel. Once these are connected, we can determine that this is Ri equal to Ri plus Ri. And as they are in parallel and these two are in series, as these two are in series, the current is the same one. So as the current is the same one, we can determine, for example, for the voltage 2, the current 2 is equal to the voltage over the resistance. So the voltage 2 is equal to the resistance 2. And as the current in 2 is equal to the current in 3, so this will be exactly the same as the voltage in 3 over the resistance in 3. Once we know this, we can take this out of the equation in order to obtain first the voltage in 2. So for obtaining, we can cancel this part and we use these two terms. So we can say that the voltage in 3 is equal to these two, the voltage in 2 over the resistance in 2 times this part that goes up, the resistance in 3. Once we know this, we can go back to this part, that is that our voltage 1 is equal to the voltage 2, that is exactly this time, plus this part, that is our resistance into 3 times our resistance in 2 plus our voltage times our voltage 2. This part is exactly the same one as this part. Once we know this relationship between the voltages, we can get the relation of the voltage 2. We can factorize it and we can obtain that the voltage 2 is equal to our voltage 1, that is 1.5 over 1 plus R3 over R2. That was the factorized part of getting the voltage 2 out of this operation. And this will be equal to 1.5 over 1 plus, and resistance 3 is 6 over resistance 2, that is 4. So here is 6 over 4. And this is equal to 3/5, that is equal to 0.6 volts. So our voltage 2 is equal to 0.6 volts. Once we know our voltage 2, we can we know this part and we know this part, but we want to determine also the voltage 3 in here. So for determining the voltage 3, we go back to the formula of voltage 2 equal to resistance 2 over resistance 3 times voltage 3. So we go to this part. Okay, but we are changing this to this goes in this part, this goes in here dividing, and this goes here in multiplying, and then we obtain this one for obtaining our voltage 3. So once we know this part, we can substitute it in this part again as we did it in here. So the voltage 1 is equal to the resistance 2 over the resistance 3 times our voltage 3, that is B2, plus our B3. And now we are only using our voltage 1 and our voltage 3, and we are leaving the voltage 2 out of the operation. Once we determine this part, we can factorize our voltage 3 out of the operation as we did it in here. And we can determine the voltage 3 by now, and say that the voltage 3 is equal to our voltage 1 over the factorized part, that is 1, plus our R2 over our R3, that is this part in here, factorized, and this is equal to 1.5 plus 1, over 1, plus our R2, we said that it was 4 over 6, and this is equal to 9 over 10, that it's equal to 0.9 volts. And this is the voltage, the voltage of the B3, that is the potential drop of our voltage 3. So now for the part B, I'm going to do it in here. We are asked to find the current in each resistor. For finding the current in each resistor, we want to determine that our current is equal to the voltage over our resistance. So the current is equal to the voltage over the resistance. But if we want to determine the current in one, we have to determine the voltage in one and the resistance in one. So the voltage in one is 1.5, and the resistance in one, we said that was 2 ohms. So 1.5 over 2 is equal to 3/4 of ampere, that is equal to 0.75 amperes. This is for the first current. For the second current, we want to determine it exactly the same. So we know now the voltage in 2, that was this part, 0.6 voltage, over our resistance 2, that was 4 ohms. So we use 4 ohms, and this is equal to 3/20, that is equal to 0.5 amperes. But as we said, the current in 2 will be exactly the same as current in 3 because they are in series. So here, this will be exactly the same as the current in 3. So now we have the 3 currents as in current in 3. Now we have the 3 currents that are asked to obtain in the problem.